So the things to take note for good controls, okay, because all these control loop, they are not independent. In fact, they are interdependent. So that means if you do some changes to the temperature, for example, it will affect downstream. It may affect your damper, the damper may affect the static pressure will affect the VSD. So it's actually, there are 2 or 3 loops that are always connect together, okay. So you have to take note that if you adjust any set point, adjust any parameters, there is a repercussion, okay, of the effects, okay. So the system will always try to correct itself, okay, by trying to achieve steady state and trying to achieve the set point, okay. So if it always cannot achieve the steady state, that means is your set point, there's something wrong, okay, there's something wrong with the set point that you're using or some sensors problem, okay. There's always an upper and lower limit. For example, if I want my temperature to be 10 degrees Celsius, it's impossible, okay, there's a limit, okay, the coldest it can get maybe is only 21 degrees or 20 degrees Celsius, okay, so your static pressure cannot be super high also, even if you want it, because there's always a limit. So your set point should be set to a realistic value whenever you are trying to adjust the set point, okay. So for building control, usually a PI control mechanism is used, okay, proportional integral, okay. So this one is about the control side, which I will not elaborate, okay, because usually we use PID, okay, PID. So for building controls, usually PI is sufficient, okay, to achieve your set point at appropriate timing. So let's look at why do we say that the controls are interdependent. Okay, let's look at some case study. For example, let's say the room is now 24 degrees Celsius and you want to reduce it further to maybe 21 degrees Celsius. What will happen? Okay, so since the space temperature now is higher than the set point, because you have already lowered the set point, it will try to correct itself. Okay, so it will correct itself first by open up your VAV damper. Okay, so your VAV damper maybe initially is 60% open, it will throttle open to maybe 20%, to 60%, 70%, 80%, and finally maybe even to 100% open. And when you do that, okay, the next thing that may happen is your static pressure in the duct will start to drop. Why is that so? Because when you have more opening, there is more so-called leakage. Okay, so there's more avenue for your air to go out. So the pressure in the duct will be will decrease, will drop. So most probably it will drop below the set point, and to correct itself, it will have your VSD, okay, the fan, right, will start to increase in speed to churn out more air, okay, such that it will build up the pressure to the set point level again. Okay, and finally, when your space temperature is not achieved, okay, even at 100%, then your supply air temperature set point may have to be adjusted. Okay, that means after doing all this, right, your fan is running at full speed, your damper is running open at 100%. If you are still not able to achieve your temperature, let's say at 20 degrees Celsius or 19 degrees Celsius, what will happen is you may have to adjust the set point over here. So let's say the set point initially here is 14 degrees Celsius, your off-coil temperature. You may have to adjust to maybe 11 degrees Celsius, such that the air that comes out is colder, and it may help to get a cooler temperature in the room. Okay, so your chilled water valve will start to throttle open. So all this is so-called interdependent, okay, whenever you want to do some changes. Okay. The second case study that I want to talk about is your CO2. So your CO2 level, let's say, is higher than the set point when the occupant level increase. Maybe during a meeting, okay, or in a conference, there are a lot of people going into a space, CO2 level increase, your fresh air damper will start to open. Okay, when your fresh air damper start to open, your mixed air temperature will start to increase. Okay, so you imagine the inlet mixed air temperature, okay, will start to increase in temperature. When this temperature increase, most probably, okay, your supply air temperature will increase accordingly. Okay, so initially the air that comes out is around 14 degrees Celsius, but because your inlet temperature increase, maybe it will come out at around 15 or 16 degrees Celsius. So when that is happening, your chilled water valve will try to correct that. Okay, so your chilled water valve will start to open to make sure that it generates enough cold water to bring down this high mixed air temperature to the desired set point at 14 degrees Celsius. Okay, so these two loops are interdependent again.